Alright guys, so before we get into using our equation F is equal to NBI or sine theta to solve for the force acting on a wire, I just want to make sure that we can actually determine the direction of the force which is acting on the wire. So we know that force is a vector, so we need to solve for magnitude using our equation, but we also need to solve for direction using our right hand. Okay, so the right hand palm rule is the one which you may have used in year 11, but we're using it again here in year 12, and that is where our thumb is equal to the direction of conventional current. Our fingers are the direction of the magnetic field, so your knuckles is the north pole, your fingertips is the south pole, and your palm is the direction of the force experienced by positive charges, and the back of your hand is the direction of force experienced by negative charges. So applying our right hand palm rule to these four scenarios, which I have up here on the board. Okay, so again, your fingers are representative of your magnetic field. In this case here, we've got the magnetic field which is moving up the page, so that's saying that your fingers are pointing up the page. Now this single arrow here represents a current carrying conductor. Okay, and the direction of the arrowhead symbolizes the direction of conventional current, okay, through that wire. So this is saying the conventional current, or the flow of positive charge, is towards the right. Okay, so we know two things about this. We know the direction of the magnetic field. We know the direction of the conventional current to the right. Therefore, my palm is facing out of the page. So the direction of force experienced by that current carrying conductor is going to be out of the page. Our second current carrying conductor here, we've got again magnetic field going up the page. We have our current carrying conductor to the left. My palm is facing towards the page or into the page. So again, the direction of force is into the page. In this scenario here, again, magnetic field up the page. Now the circle with a cross in it, if you remember from year 11, again when we did fields and we were trying to represent a three-dimensional field using a two-dimensional piece of paper, we have to use dots and crosses. Okay, so crosses represent a field going into the page, or in this case here, a current carrying conductor carrying current into the page, and those dots represent something coming out of the page, either a field or again a current carrying conductor with current going through it. The difference between fields and current carrying conductors is really subtle. Here, the current carrying conductor has a circle. That circle represents the wire. So this is saying it's a wire with current going into the page. Okay, whereas over here we've got our field represented by the crosses going into the page, no circles around it, indicating they're not current carrying conductors, rather it is a field. Okay, so in this scenario here we've got our magnetic field going up the page. My current carrying conductor is carrying current into the page, so now my force is towards the right. Okay, and the last one here we've got magnetic field into the page. Again, my thumb representing the current carrying conductor going down the page, and again force towards the right.